Previous lectures, we have discussed about the inductance calculation for three-phase symmetrical line. Now, in this lecture, we are going to discuss about inductance for unsymmetrical line. So, here I am discussing about the previous inductance of three-phase symmetrical line. So, here you can see when the three conductors, phase conductors A, B, C are placed at equal distance for symmetrical line. This is the diagram of that symmetrical line. Now, in this derivation, we see the lambda A, that flux linkages for phase A conductor is equals to 2 into 10 to the power minus 7 IA ln 1 by R dash minus IA ln 1 by D plus IB ln D PB by dPA plus IC ln dPC by dPA. So this is the equation, the ultimate equation of flux linkages for lambda A. In this case, we consider a external point P situated at infinite distance. So it is very, very far from the system, P point. Now, due to this point P, we have two terms, dPB by dPA and dPC by dPS. These are the two distance ratio. Okay. So as for this case, as the P is situated at infinite distance, so to approximate it, we can consider dPA equals to dPB equals to dPC. These all are tends to infinity. So what will be the ratio? The logarithmic, that their ratio must be 1. So log 1 equals to, as you know, log 1 equals to 0. So the logarithmic ratio of dP by dPA and logarithm ratio dPC by dPA must be equals to 0 because log 1 equals to 0. So finally what you have, that is 2 into 10 to the power minus 7 IA ln 1 by R dash, the effective radius of the phase conductor minus IA ln 1 by D. D is the distance from the other phase conductors B and C. So here this dPA, dPB and dPC, these terms will vanish. So in my next lecture, we're going to discuss the derivation without considering any point P, external point P. So ultimately here you can see the ultimate flux linkages 2 into 10 to the minus 7 IA ln d by R dash. So the final inductance LA equals to lambda by IA, which is equals to 2 into 10 to the power minus 7 ln d by R dash. So here no sign of point P. So in next derivations we are not going to consider any point P. We are consider only 1 by R dash and 1 by D as written here. Now, at starting next topic, inductance of three-phase unsymmetrical line. For unsymmetrical line, here you can see we have three conductors A, D and C. These are the three conductors, but they are not equally spaced. So the distances are D12, D23 and D31. So A conductor placed at 1, position 1, B conductor at position 2 and C conductor at position 3. And depending on these three positions, we have the distance D12, D23 and D31. And this will not make an equilateral triangle because these are not equal. So ABC are the current carrying conductor and they will carry current IA, IB, IC respectively. So these are unsymmetrically spaced. So as I said earlier, D12 is not equals to D23 is not equals to D31. So each conductor has radius R meter. Now, flux linkages of conductor A, B and C due to current IA, IB, IC, it can be written as, from our previous knowledge, it can be written as lambda IA, which is equals to 2 into 10 to the power minus 7 into IA. IA is the self current IA is the self current of phase A. So, and R dash is equals to R dash. R dash is equals to 0.7788, 0.7788, that is e to the power minus 4 into R. This is the effective radius. This is called the effective radius. So, in the next part, in the next part we consider other phase currents, that is IB and IC. Consider IB, this IB and IC. Now, B conductor is placed at a distance D12. So the term IB ln 1 by D12 and IC ln D ln 1 by D31. So this will be the ultimate equation of lambda A. The next, similarly, the next equations are, if we consider B conductor now, then what will be the flux linkages lambda B? Lambda B equals to 2 into 10 to the power minus 7. IA ln 1 by D12. So A placed at D12 distance. Then IB ln 1 by R dash, IC ln 1 by D23 distance. The distance is now D23 from B to C. And the third equation is lambda C 2 into 10 to the minus 7 IA ln D1 by 31. This is the distance between A and C, plus IB ln 1 by D23, distance between B and C, plus IC ln 1 by R dash, because now IC is the self current for C conductor. So these are the three equations for three flux linkages of three conductors or phase conductors. Now, the next part, we are considering some operator, that is symmetrical A operator or symmetrical operator. Here, what we do, we consider for three phases A, B, C. In balanced condition, what will happen? A phase, B phase, and C phase, they are equally displaced by an angle, equal angle, that is 120 degree. So now, for lambda A, we are considering A as a reference. So for lambda A, we are taking A phase as a reference, and C phase, it is displaced by an angle 120 degree in anti-clockwise direction, and B at an angle 240 degree in anti-clockwise direction. Now, after taking A as a reference for unbalanced three-phase system, IB can be written as alpha square IA and IC equals to alpha into IA. So this alpha is just alpha, we are using alpha operator here. Now in complex number, you are familiar with J term. Here we consider the real axis. At 90 degree, we are having J. At 180 degree, we consider J square. And at 270 degree, we consider DQ. Now, J equals to square root of minus 1, as you know from your previous knowledge, square root of minus 1. And it is at 90 degree from the reference. J square, it is 90 plus 90, that is 180 degree from the reference, and J square is equals to minus 1. J square equals to minus 1, and JQ at 270 degree, this is equals to minus J. So here what we consider some J operator for complex number. And here the angles are taken 90, all are equally divided 90, 90, 90, 90, total 90 and 4 quadrants. Similarly, in case of symmetrical operator, total 360 degree is divided into 3 parts, equal part 120, 120, 120. Therefore, if we consider A as a reference, so at 120 degree, that is IC. If we consider IA at phase A, this is taken as a reference. So C or IC, it is displaced by 120 degree and it will be alpha into IA. In complex number, we consider J into some real part. So here it is alpha into IA, not J, alpha. And IB equals to alpha square into IA. Now this alpha can be written as minus 0.5 plus J 0.866. This is alpha. Actually from Euler's equation, alpha is equals to e to the power j theta, where j is actually 120 degree, e to the power j 120 degree, j 120 degree. Now j 120 degree, now it can, how it can be written? It can be written as cos 120, that is cos theta plus j sin theta, cos theta plus j sin theta, cos theta plus j sin theta. So e to the power j theta can be written as cos theta plus j sin theta, where theta is 120 degree. So for 120 degree, that is what we get, minus 0.5 plus j 0.866, that is sin theta. All sin tan cos, this is the quadrant. Similarly for alpha square, this theta, it becomes 240 degree. For alpha square, what will be the theta? Theta equals to 240 degree. For 240 degree, cos 240 degree plus j sin 240 degree. So finally what we get, that is minus 0.5 minus j 0.866. So this will be the expression of IB, alpha and alpha square. So now we're applying these two equations in IB and IC. So what will be the equation now? Flux linkages lambda A now can be written as 2 into 10 to the power minus 7 IA ln 1 by r dash, IA ln 1 by r dash, plus that is alpha square into IA, that is alpha square into IA, and alpha square can be written as minus 0.5 minus j 0.866. So ultimately IA into minus 0.5 minus j 0.866 into ln 1 by d12. Similarly, IC can be written as alpha into IA, or this can be written, this is actually IC. IC can be written as alpha into IA or IA into minus 0.5 plus j 0.866. So this will be the equation for flux linkages lambda A. So apply, I am writing this equation again, same equation. So in similar fashion, we can also have, so here we can, from lambda A, we can calculate LA, that is inductance LA in phase A, that is lambda A by IA, lambda A divided by IA, and it will become, after cancel out, IA term will cancel out. So finally we get 2 into 10 to the power minus 7 ln 1 by r dash minus half ln 1 by d12 d2 3 1 minus j root 3 by 2 ln d31 by d12. So this will be the inductance LA. In the now after simplifying this, real part and imaginary part are separated, and finally we get 2 into 10 to the power minus 7 ln root 3 d1 to d31 3 1. So here we are having one term half. Now if we take it inside the log term, then it becomes a square root of d1 to d31 divided by r dash minus j root 3 by 2 ln d31 by 2 1. So this will be the equation for LA. In similar fashion, we can also find out LB and LC. LB will be 2 into 10 to the power minus 7. So here we consider IB as a reference. So in the diagram, we consider IB as a reference. So after calculating by the same process, we get 2 into 10 to the power minus 7. This is the previous equation. So after taking alpha and alpha square operator, we get LB equals to 2 into 10 to the power minus 7, ln 1 by r dash minus 0.5 plus 0.866 ln 1 by d12 plus minus 0.5 minus j 0.866 ln 1 by 2. In the similar fashion, we get this equation. Ultimately, this we get this equation to LB. LB is the equation, that is 2 to 10 to the minus 7 ln square root of d12 d23 by r dash plus j root 3 by 2 ln d23 by d12. This will be the equation for LB. In similar fashion, you can find out LC, but here consider C as a reference, C phase as a reference, or IC as a reference, and this is the equation for LC. And after simplify it, we get this last equations. Now here the three inductances are written again. These are the three inductances. So here you can see, as the three distances D12, D23 and D31, they are not equal. So LA, LB, LC, these inductances are not equal. Okay, so but this is not desirable. This is undesirable because this will make the system unbalanced circuit. That is unbalanced system. Now this is some general equation. From this equation you can also derive the equation for symmetrical line. So for symmetrical line, what will happen? D12, D31 and D23, these three are equal. So in that case, in case of symmetrical line, D12 equal to D23 equal to D31 equal to D31. To D31. So these three are equal. So if we take this equals to D and replace all this distance by D, then what will happen? Ultimately we get 2 into 10 to the power minus 7 ln, so square root of D square, it becomes D, so ln D by R dash, that is ln D by R dash. And the other term with J part, this part D by D, D31 by D12, say both become D by D, become 1, so log 1 equals to 0. So this imaginary term will vanish in case of symmetrical line. So from here also you can derive the symmetrical line. But it is unsymmetrical spacing, so we cannot get LA, LB, LC equal. So these three are unequal, okay, or different value. And this is undesirable because it makes the system unbalanced system. So this is one kind of problem. Therefore, we go for transposed three-phase connection. I will discuss this topic in my next lecture.